So it's the next day. I've been very boosted by my success from yesterday. This little guy you saw. I did a little bit of what do you call it? Burrs. I knocked the edges off. I cleaned up the edges a little bit. I deburred is the word I wanted. I deburred the edges a bit. I'm going to go for another one because I needed 2 of these anyways. So I'm going to cut another one. And this time I've set up, you can see here, I got a little air nozzle, or a little nozzle thing. I'm going to try an air blast right up by the cutter here. Can't see yet, but I'm going to try an air blast and see if that helps get a better surface finish, because I had a little bit of recutting of chips on the last one, and it was getting a little warm. So if I can blow some air, it'll keep the area cooler. And I'm hoping I'll get a bit better surface finish. The inside hole, it's not perfect, it's not awesome surface finish, but it's way better than the outer edge, and I think that's partially because it was cooler and it cut faster, or because it was cooler, it cut better. So I'm going to give this another go. I'm going to just pan out, and you can watch the whole process. I'll probably speed it up a little bit for you here. So here goes the second part, like this, another stepper mount. So be right back. Alright, well, I can say one thing for sure. The air blast kept it from welding chips to the side, and it feels better. So let's get this guy out of there. There's some promise and some hope here. It's a little, I mean, it kept the part cool too. I don't have a lot of heat in it, which is great. I ran the air compressor the entire time, although it does appear my holes are not in the same spot. I may have lost some steps. Yeah, I think I might have. There may have been some steppage lost. These holes are not where they go. That's okay, because the milling machine will take care of it, but what I'll do is I'll gang these up and I'll cut them together, I guess. But edge finish, not great, I'll say that. I do think I lost steps, because there's a ridge here toward the end, I think. Could just be a flange. These holes are in the wrong place because there was flex and I was way too deep when it went. So yeah, that's part of it. But part number 2, I'm gonna go deburr this real quick and review what I've got, because I think we might be ready for the third part. Hold on a sec. Okay, third part now is the last stepper mount. This one's for the x-axis, and it's mounted different. It's going to be just a square. So we're just set up. I've got the V-bit in now. We're going to mark our holes. We're going to do just like I did the last time. But this time I only need to do the corner holes instead of the center hole, because it's a square and it'll hold it enough. So we're ready. I'm going to put on the hearing protection real quickly, and we're going to get after this. no, that one, while it did have a little melting going, a little welding going on, the heat got a little bit more than I was hoping for, but it wasn't terrible. It was not obnoxious. So as long as those holes are bigger than I need them to be, which they are because those will be mounting holes. These are the ones that need to be smaller. Surface finish, this one's got a lot of welding in it, unfortunately. You can see. Well, but on this side, completely 90 degrees from it, or 180 degrees from it, is good-ish. About what the other one was. This side's pretty good too, and this side's okay. It's got a little welding. That last one though, that's got a fair bit of welding in it. I'm going to quit doing that because it's going to slice my fingers out. But part number 3 off the machine is not bad. My stepper hole is pretty good, so that's good. All right, so we're done with 1/4 inch stuff. We got to move up to the bigger stuff. So those are going to be pretty simple parts. Thankfully, they're just deeper cuts. So bring you back when I'm ready for that. Okay, so the next part, this is the table for the machine. It's tricky in that this blank is only about maybe 1/8 of an inch oversized in either direction. So very little part, very little part to be there, or very little allowance for error. Ooh, excuse me, very little tolerance for error is what it kind of comes down to. So this one, it's kind of important that I'm fairly parallel with the axis, but also it's a complicated part because there's a bunch of holes, and a few of them are counterbored. 16 of them are counterbored for the bearing trucks. So it's going to be a little juggling of tool changes and things like that. But the first thing I want to do is get it held down. So there's also a work holding challenge. I'm going to be profiling the outside of this thing, but I'm going to be right on the edge of this material. So I'm going to be cutting all the way around, so I can't have any clamping on the outer edges like I did on the last parts after a certain process. So the first thing I need to do, get it clamped down and locate the holes I'm going to put in there to fasten it to the table. In order to do that, I also have to get the counterboring done. So there's a little bit of juggle happening here. I've got to do some locating to get the V, to get the left and right, the X and Y center, get things located. Then I got to swap out and cut the counterbores. Then I can come back. I want to make sure I peck those little centers of those counterbores so that they end up in make it so I can drill them easier. Anyways, it'll make sense here. I'm going to go through this step by step. So first thing I need to do, here's a little bit of the CAD and CAM for this part because it's unique. Okay, so we're going to do the CAM for the table part. This is a unique one because it's got some features that we're adding through the CAM software through CAD this way. So we're going to start with a new file that is 6 5/8 wide by 6 1/8. Remember, this is my material size. This is the raw material size. We're starting in the lower left corner. It is a 1/2 inch thick, and we're going to say OK to that. Okay. Now we're going to bring in our SketchUp vectors by picking the table, and again, just the default stuff. This just gets it into the app. We're going to center it. And so we've got quite a few holes here, and one of the things we want to do is first I'm going to ungroup this whole set because I need to do different things to different stuff, and then these holes for the bearing trucks will need to be countersunk, or not countersunk but counterbored. They'll be oversized and I need a flush surface, so they'll be counterbored. And so we're going to just add a couple of circles to these. So the first thing I'm going to do is I'm going to set up some circles that are just a hair over 0.502, for example, because I'm going to use a 1/2 inch end mill to make this cut. And I'm not entirely sure whether the 1/2 inch end mill can actually plunge, and I'm figuring leaving it a little bit oversized might get a little bit of a spiral action going. But we find out shortly that may or may not be the case. So we're just going to create our circles centered there. I'm just going to make all 16 of them here. And as boring as this might be, just get them all in. Okay, those are all in. Now, one thing you're going to see in the actual machining operation is that I did not get the counterbores for these 4 holes. These 4 holes get the bolts to hold the lead screw nut on, and they do in fact need to be counterbored, so I'm going to model them. You're just going to see in the footage that you're going to see after this, I had forgotten to do that, and so you're going to see that recovery later, but in reality I'm going to model all of the counterbores that I need. Then I'm going to select them all, and I'm going to use some lazy selection tools here, just like that. Do this. So if you grab from the right and head left, it selects any vectors it touches and not encapsulates, just touches. So I'm just going to do that and then deselect those. So we've got 16 plus the 4, so we've got 20 of these vectors selected. We're going to do a profile toolpath again, and the reason I do the profile toolpath, I'm not sure if I explained it in the last video, but the reason I'm doing the profile toolpath is that it allows me to do a spiral. So if I set the show advanced toolpath options, I can add a ramp that is a spiral, and that's what I want. I want it to basically helix its way down to the depth. And for our depth of cut, it's actually 3/16. Because the cap screw's height is shallower than that, is lower than that. We're going to use our 1/2 inch end mill for aluminum, and in this case I want to plunge at 10 inches. Well, actually we won't do it here. We'll select our 1/2 inch tool and we'll go here and say do it at 10 for the feed rate, and that feed rate is 10 because I know my machine doesn't like to plunge real well, so I'm hoping to go really slowly and take care of any issues there, or any rigidity problems there. So hopefully that keeps it so it can still plunge correctly. That, and I think we'll just call this counterbores, and then we'll close this. So we've got our counterbores in. The next bit that's a little bit interesting is we're going to have to split up the spotting task of spotting the hole locations, because now the spotting I need will have to be below the surface for the ones that I've done the counterbores. I need the spotted hole center down inside the counterbore. So the first thing I'll do is I'll pick these other holes and we'll do the same spotting path with the drilling tool path, just like we've done in the other one. And we'll use our V-bit. We'll go down 10 thou. These we'll call surface holes. We'll calculate those, and that just puts a little tick in there now. And then for the other holes that are the counterbore holes, we can just click on this toolpath that was the counterbores, and that selects all those holes for us. We don't have to go through a bunch of trouble. Either hole, the bigger or smaller hole, will work for this task. And so we just picked the big one because we'd already selected it. Now we're going to take the drilling toolpath once again, but this time we're going to say our start depth here is 3/16, which is the depth of our counterbore. We still go 10 thou. That just means go down 3/16 of an inch, then consider yourself drilling for 1/10 for 10 thousandths. And then we'll call these the sunken holes. And we can calculate. And then after we do that, we grab this path and we do another profile. And this time we go down 51 thou, or 510 thou, excuse me. We do the same tool path with the aluminum. This time it's the, oh, that one remembered, so we're going to go back and pick this tool at 20 thou, or 20 inches per minute. And we'll do outside. And we're going to play back and forth with conventional and climb milling. I think we'll do this one with the conventional and see how it does, and then later we'll start experimenting with climb passes. We'll do a separate last pass of 2 thou like we did the last time, adding a spiral ramp. Start at optimize the start points, and then we'll save this as outside. call that good. Yes, it's going to yell at me for going through this. That's fine. Let's say close, and we're going to go preview this. Now what you're going to see is first we're going to do, well, when I run this, we're going to first run it to do the counterbores. So those will be in place. Now obviously they won't have these four because I had forgotten to model them up. I've already done this once. And I should have modeled them like this, but I didn't. I'd forgot. Then we're going to do the surface holes and the sunken holes. We'll basically save those two files together. So we'll preview those, and you can see barely. There's a little tick there, a little tick there, a little tick there. All 5 of those, and we'll do our sunken holes next. Preview that one. Those should be down inside. See how they put a tick down inside the hole? Okay, we'll re-zero, and lastly we'll do our outside profile. There we go. So one of the things you see, the counterbores are right up against the edge. I'm going to resize this a little bit in the actual cutting later by, I believe, about 1/8 of an inch, just to get a little bit more wall there. So that's going to be something to help kind of maximize our part out of this. But that's about it on there. We're ready to save the toolpaths next. We're going to do a real quick check, see how long we're going to take. Yeah, that outer cut is going to take a little bit of time. We might play around with feeds and speeds there a bit to see if we can't speed that up, but because it'll mostly be outside cutting, and we might be able to get away with speeding that up. But the first thing we'll do is go to save. Okay, so we're going to have one for the counterbores. We'll save that here. We'll call that, I'm just putting numbers in front of them so that I can keep them in order. The second file is going to be both V-carving toolpaths, because we can do them both at the same time. But between these two, actually no, these are all going to run. Well, between these two, we'll change the cutter out, obviously. So we'll have the V-carving. We'll save that as operation 2. Then once that's done, we'll drill out a couple of these holes because they're going to become my fixture. They'll be my hold down. Probably this one here and this one here, I think. Then we can undo those. We'll do this one as the outside. Then we'll run this as operation 3 with another cutter change. It's a little bit of weirdness. We're going back and forth on cutter changes to kind of make this work. But this, because of the counterbores, I need them in place, and I also still want them center marked. I'm going to have to do it this way to make sure I can get things right. I'm also going to play around with finding the X and Y 0 for this. I'm going to use, since I'm going to start with a big 1/2 inch bit, I want to get the X and Y 0 pretty precise, because you can see this is the outside of our part and the white is the outside of our material. And like I said earlier, I was going to make this a tiny bit larger, so we're going to get even less wiggle room. So I need to get that lower left corner really, really precisely located. And we're going to do that with a V-bit, and you're going to see that next. All right, so first thing I need to do is align along that left edge. So remember, we're here. So this is the Y-axis, and this is the X-axis here. So X, Y, okay? And so along the Y-axis is the widest part. So I've got the wider edge, wider orientation here. And I'm pretty close to the middle of the travel of the machine. And I'm just going to hold it against this while I drill a hole here. And so because I have to machine counterbores right up to these edges, you saw that in the CAD, there's counterbores in each of these corners. I can't hold it with the existing holes on this side because I am probably going to be counterboring right where that's holding. So we're going to put one there. I'm going to hit every long edge here is basically what it's come down to. Is I'm just making new holes. That's why we made this goofy fixture in the first place. I'm going to come up a little bit here. Okay, and then I'm going to come over here about that far. And same over here, about that far. Okay, and so those are pilot holes for the screws that are going in. I'm going to set those up next. And we're going to hold it along the center of each edge because that's the only place I'm not machining first. I need to machine the counterbores so that I can drill the holes that will actually hold this part to the table. You'll see that momentarily, but first we'll get all these screws started, and then I'm going to take and put put a washer. I have a feeling this might be a little too much for this washer situation. Oh, maybe it's fine. So I'm going to get one there, and I'm going to get another one on this side. And I'm worrying mostly about... Oh, no, I put that hole too far away. So this one is not going to catch it. So what I need is I need to put a... actually, what I'll just do is put the hole closer. Yeah, I'll just put the hole a little bit closer. We'll put it here. Okay. And we'll put that hole with the washer. Okay. And just do a washer here. There we go. Okay, that'll push it against the fence, and this one will push it down and hold it. Okay, that's doing its job nicely. Okay, now we can do these sides. I have a feeling, yeah, that one's probably not going to work there, so we'll drill a new hole for you. It's not in the middle anyway, so. And that's why we made this fixture, so I can finagle this little bit by little bit. If I really wanted to put together like a serious clamping system, I could, but I don't need to in this situation. These are literally, you saw the only two parts that are duplicated, those stepper mounts. So, okay, that one's held. This one I think is fine. I think I got close enough for this washer. We'll see real quick, I think. That. I think we're okay. Yeah, we're all right. There. That part isn't going to go anywhere for this operation, and we're well aligned with this edge, so that's perfect. That's what I needed it to do. Okay, we get all this crap out of the way. I'm going to come back and hand tighten just because I couldn't feel real well with the driver how well we were set. Ah, see, this one did not cinch down very well, so it's a good thing we checked. Okay, that's holding nicely. That one's holding quite nicely as well, as is that. Okay, that part isn't going anywhere. Good. All right, and my corner is clear. So one of the first thing I'll do is bring it over, and I will change out to the V-cutting tool, but I'm not going to actually cut with it. I'm not actually going to cut with this tool right now. Just going to use it to locate this tiny corner right up here. And the sharper point that I have, the better. So we're just going to switch out and use that V carving tool. I could do half of the holes with this tool change, but it's not really a big deal. It's not going to change much. So we're just going to put in the other tool. And I'm holding you through this process because I think it's worth illustrating what the challenge is. So that part just has very little room inside this workpiece, so we have to get creative a little bit. All right, so now we can drive over. And I'm going to get down on my... Now we're going to get right close here. We get down even further here. And now I am going to watch that point until it's spot on with that corner. And I would be hard pressed to call that anything but perfect right there. Okay, so my X and Y, I have to be within at least way less than 1/8 of an inch, like probably more like a 32nd, and I think I'm there. Okay, so now we're going to, I'm going to head towards the center to zero my Z, because I figure if there's any bumping or lumpage, should be in the middle. And now I'm just zeroing this. Oh, I don't need to zero the Z for this. I forgot about that. We're going to switch out the tool now, because I'm ready to do the end mill, because the first step is I'm going to counterbore the holes, so that because I also need to spot where I want to drill the holes, but those spots have to be down inside the counterbores. So we have to do that first. So we'll switch back out to the end mill. I know that seemed like a weird thing, but I don't have a good locating setup on this CNC. Someday I will, but it's not there right now. And yes, I know there's a lot of ways, there are a lot of solutions. It's what I have at this very second versus what I could have if I put a delay on my project and went to do that. Like, I have a plan to get a probe system to find zero on things, but I don't have it created just yet. Okay, now we can find zero on our Z. So we'll come down here. And we'll just go till she's close. Na, 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 na. Okay, that's really close. And then just go until I feel the friction. And then I drop it another 4 or so thou. Call that Z0. And I click on that. Now I can load some G-code. Okay, we got our G-code. Everything's ready to go. I've got my air. I'm a little nervous because these are pretty much plunges. I've got to think I've done the hole size like 2 or 3 thou over. So these are going to be some pretty... I'm worried about the cutter, honestly, but they're only going 3/16 of an inch deep, so hopefully we don't have a big issue. So get the air going here, and we'll get this running. Okay, that was a big fat hairy nope, because my feed rate was way too high. So I'm going to reset, and we're going to change my plunge rate. Was way too fast. That was just gross. We're going to knock that plunge rate way down. We're going to go super slow. Man, that just got jagged as hell. So, okay, so we got to make that feed rate incredibly slow. It was at 10. We're going to go 1. We truly are going to go super slow. And my part moved, so I'm going to have to fix that too. Okay. That was a hairy job right there. I did not like. We're going to try this again after I reset a little bit. That's not a big deal. It's a counterbore hole anyway, so it's not a huge problem, but I want to make sure I get it right. I'll bring you back in a second. All right, so we've got it back in place. I've got the right G-code now. Ready to go back at this. Let's get it kind of closer to the... I don't know if I lost any steps. I'm going to reset my Z just in case, because I don't really know for sure. Let's see how far away we are here. Still free? Yeah, we're still free. We're 11 thou, 10 thou. That should be 0. Wait, one more. We'll go a little lower then. There it is. That's 0. Okay, I'll call that 0. Okay, back up we go. And we're going to load that G-code and we're going to try it again. This time much slower. 1/10 of the speed. So fingers crossed it's not too violent. And we've got a decent hold on everything. Fingers crossed. Fingers crossed. I might... Yeah, I don't know. I could do that. Okay, if this one doesn't work, I have another idea to solve this. It'll be a little more convoluted, but if I have to, I can do it. All right, let's try this. Okay, that was pretty nerve-wracking. Here, it struggled. This was pushing this machine. One, wrong tool for the job, first of all. Two, way too much work for this machine. I had to slow it down to 1/2 an inch per minute. That's ungodly slow. But, and I think most of this is, one, the end mill was not really that big of a center cutting thing. It didn't do very well at center cutting. Two, the hole was basically the same size as the cutter instead of like a 1/4 inch one. Lots of problems. It did cut them. They are cut and they're consistent. So like overall, it was a success, but it's one of those like, okay, the next ones I have to do that need counterbores, I'm going to do a very different way, because that was very nerve-wracking, very, very nerve-wracking. So I'm not going to do it that way. Plus, I believe my part shifted because the holes, these holes are further away from this edge than these holes are. So I have a feeling my profiling cut is not going to reach this edge, which is fine. It happens to be a sawn edge, an edge that's very straight anyway. So I'm not terribly upset that I didn't reach that edge. It's okay. So we're going to switch out. Holy crap, that was scary. We're going to switch out to a V cutting bit so I can put I want to mark the holes locations now. So that's next. And then I'll drill a couple of them out and use them to mount the plate down so I can do the outer profile. Alright, so real quick we're going to switch to the V bit. I'll be right back. So I did the little pecking. It seemed the non-bottoming end mill did not cut quite as deep as I want, but that's okay. That just made the tops very shallow. So I'm just coming back. The shallower ones are a little too shallow. So I'm just coming back with a spring-loaded punch to get those good and well and truly obvious while I've still got this lighting and, you know, just while I remember where they are, because I watched it do it. So I'm just making sure those are visible, so when I go to drill them later, I will have them drilled in the right place. That's a good thing. I don't actually need to do this to these holes because they are plenty deep. So I'm just going to take this here drill and yeah, we'll do it with the small drill first. I'm just going to do a couple. I don't need many. All we're doing is holding this part in place. And I'm going to go for this one here. Like so. Yeah, and then we'll do this one over here. The nice thing is that these holes will be drilled a fair bit oversized for the 6mm cuts, or the screws that are going to be holding it down. So it's not a huge critical centering thing, as long as I've, you know, not worked out the tolerance of the handhead screws that I'm going to use, the button heads. So we just need a couple of screws to hold all this down. Okay, now just a couple of screws will take care of it. And then I'll bring you back here in just a second when I'm ready to profile. Oop, nope. We are going to go with, oh yeah, these screws are a little short. Let's go with one that's a bit longer. Yeah, this might be too long actually. No, that's perfect. Okay, that'll hold everything in place. I'm going to get the cutter changed out and get it ready. I'll get these screws removed and get it ready to profile. Okay, cool. So as I thought, it didn't really cut on this side at all. It might have skimmed, maybe, a tiny little bit, barely, if any. So that's okay though. I don't think it was off by much at all, really. This did get some re-welded cut, some recutting going on. This side is great. That has really good cut quality on that side. But the important part was these two sides were bandsawn and they were wavy, so those two got engaged tool engagement. So we're going to pull this off of there. There's a little bit of flange down here, a little bit of flashing here, so we're going to take this out. I think we're done. Yeah, we're done. I'm going to take this out of the machine, bring it over and deburr it, and I'll catch you up here in just a second. Yeah, this is pretty good. Yeah, this edge didn't get cut at all. Nothing touched it. So it might be, you know, 20 or 30 thou smaller than it should be. But overall, definitely not the right tool for the job to do these counterbores. I'll do those differently on the next ones. But in the end, this got me where I needed it to be. So we're going to go deburr this before I slice my fingers up. We'll be right back. Alright, so I went and deburred everything. We're good to go. That's going to be fine. I did realize I forgot a step, or I forgot to do one thing. I forgot to counterbore these 4 holes. These 4 holes are for the lead screw nut, and you can see them here. Let me see if I can get you a shot of how pucked where they are. There you go. Those 4 holes right there are for the lead screw nut, and they need to be counterbored as well, and I forgot. But this distance is small enough. I think I can fit it in my vise on the milling machine. So when I go to drill these, I'll also counterbore them as well. So not ideal, but the next part that I do, or the next parts that I do that need the counterboring, I will do for sure. And I'm going to do the counterboring in a much more machine-friendly way. But overall, I will say this, I mean, my cut quality on the edges, not all great, but acceptable for my machine, for me. If I was doing parts to sell, I wouldn't accept that, but it's not a milling machine. It's just a CNC router that's made of MDF. So I'm holding together, getting it to do what I need it to do. So the next bit, I'll do another part. I'm basically doing all the CNC stuff at one shot, hopefully, because it's tying up the machine, and holy crap, it's getting aluminum everywhere. See that pile right there? Imagine some about that much all around the floor here, all over, and oh, it's everywhere. I'm going to be cleaning this up forever. So I'm going to try to do them all at once and get every part together. I'm gradually ramping up in complexity. This was probably one of the more complicated parts. The next part I'm going to do, this is the table, so this is going to go this way. This is the Z-axis plate that the router or the spindle mounts to, that's going to go up and down. It needs slightly less holes, at least slightly fewer predetermined holes. There's 16 of the bearing truck holes, and then 4 of the lead screw nut holes. So all of those get counterbored. So I'm not even going to bother. Well, so they all get counterbored, so they're all going to have the slight depth. So what I'm going to do is I'm not going to do it with the 1/2 inch. I'm going to get a smaller tool. I have a bunch of other tools that I realize now I could use for that. So I've got a 3/8 tool or something like that. I can get in there and do a spiral tool path instead of a freaking plunge that just absolutely went crazy. Although the one hole that went haywire is, I believe it's this one. Yeah, that one's the bigger one. It's not terrible either as a counterbore, so I'm not too worried about it. But yeah, we're gradually getting along. This is part number 4, and we're just gradually ramping our way up in precision and complexity. This one and this one are basically the same. There's 5 other holes here that got marked, and those are for holding the irons, but that'll show, you'll see that later. And once they're all counterbored and the center's pocked, I will take them over to the drill press and fully drill them out for the 6mm hole. For a 6mm, it's actually going to be sloppy fit. That's why they're counterbored instead of countersunk. I don't know if I explained that yet, but that's why. So this will be the next part. Maybe I'll do it do it like this one did, like here. I did cut into the fence that I was using, but it made a new fence, and this is the next part that will use that fence for it, so I'm okay with this. It's totally fine with me that it did it this way. That's actually got a little bit of the rock, so the next part will be much longer and it'll use these edges, so not a big deal. Yeah, we're getting closer. We've got 4 parts made and 1, 2, 3, 4, 5 parts to go, so not bad. I'll bring you back when, well, I'm going in because it's 1:15 in the morning, so it's time to call it a day. But I will bring you back tomorrow probably, unless I sleep till 2 in the afternoon, who knows. But we'll get this part going next, which will be the Z-axis carriage plate. So away we go. I'm going to throw in a get after it. Get after it.